Welcome, AIHT students. Let's jump right in. We're going to take your Session 3 lecture and boil it down into a super fast explainer. We're literally going to build an AI's mind from the ground up, starting with the most basic rules and working our way up to how it makes really complex decisions out in the wild.
Okay, so this is the big question, isn't it? How does a machine actually think? Well, it's not magic, that's for sure. It really all comes down to how an AI creates a model of the world, and as you're about to see, there are a few key ways it goes about doing that.
So, here's our game plan. We're going to follow the lecturer's flow, starting with the 3 big frameworks for thinking. Then, we'll get into the language of AI, see how it organizes everything it knows, compare its plans to its actions, and finally, wrap up with how it makes those tough calls when things get complicated.
First things first. Before an AI can even begin to solve a problem, it has to have a way to understand that problem. It needs a way to represent it internally. You can think of it like having a blueprint for how it's going to reason about something.
This table lays out those 3 main blueprints perfectly. Seriously, think of them as different toolkits for different jobs. You've got your state-centric model, which is all about states and moving between them. Perfect for your GPS, finding a path. Then there's the variable-centric model, which is like a master juggler, handling all sorts of variables and constraints. That's crucial for something like hospital scheduling. And finally, you have the logic-centric model. This one is the super strict inspector, using formal logic to prove that a system is working exactly like it's supposed to.
All right, so we've got a blueprint. What's next? Well, now the AI needs a language to actually express its ideas and its knowledge. For a whole lot of AI, that language is logic. Now, the key difference here is all about power and detail. Think of propositional logic like a light switch. It's either on or off, true or false. It can handle a simple fact, like the cat is on the mat, but it can't tell you which cat or what on really means. It's pretty limited. That's where first-order logic, or FOL, comes in. It's way more expressive. It lets the AI understand a world full of specific things, like this specific cat, and all the complex ways those things relate to each other.
This is a fantastic example. It shows you exactly how an AI takes a simple sentence we'd say and translates it into a formal structure it can actually understand and process. You see how there exists becomes that little symbol, the existential quantifier, and the idea of likes becomes a predicate, formally connecting a variable x to the concept of cake. This is it. This translation from our language to machine logic is how it all works.
And this is how an AI reasons. It's not just a database storing facts. It's using these formal rules of inference to create new knowledge from old knowledge. Modus ponens is a classic. It's basically just common sense, written down so a computer gets it. If the AI knows that rain implies the ground is wet, and it sees that it is raining, well, it can logically infer that the ground must be wet. It's making a connection, a logical leap, all on its own. So our AI can represent facts, and it can reason with them. Awesome. But what happens when you have thousands or millions of facts? It could turn into a total mess, right? You need a system to organize it all, and that system is called an ontology.
Yeah, ontological engineering sounds pretty fancy, but think of it like this. You're creating the ultimate hyper-organized encyclopedia for a very specific topic. It's not just a list of words. It's this rich, structured web that defines what everything is and how it all connects. This healthcare example is just perfect. An ontology is what lets an AI understand the hierarchy, that a cardiologist is a type of physician, and a physician is a type of healthcare provider. And this isn't just a neat academic trick. This is absolutely critical for real-world systems, like when 2 different hospitals need to share patient data. Without this shared dictionary, it would be total chaos.
Okay, so we've built this incredible internal mind for our AI. It has logic, it has this organized knowledge base, but what's the point if it can't actually do anything in the real world? Let's bridge that gap between thinking and doing.
This is where the AI puts on its strategist's hat. Automated planning is this really deliberate process where the agent thinks through all the possible actions to find the best path to its goal, and it does all of this before it makes a single move. It's thinking before it leaps.
And you've got to understand the difference between these two. It's so important. Planning is the quiet, cognitive work that happens behind the scenes, inside the AI's mind. It's the strategy session. But acting, that's showtime. That's where the plan meets the messy, unpredictable real world, where things can go sideways and the AI has to adapt on the fly.
So, all of this brings us to the final and maybe most crucial piece of the puzzle. Let's be honest, the real world isn't a neat and tidy logic problem, is it? It's messy, it's uncertain, so how does an AI, with all its logic and planning, handle that?
To deal with all that real-world uncertainty, an AI has a few more advanced tools in its kit. It can use something like multi-criteria decision-making to help it weigh a bunch of competing goals. It can use probabilistic models to think in terms of likelihoods and chances. And then there's fuzzy logic, which is super cool. It lets an AI reason with vague ideas like warm or close that aren't strictly true or false.
And now for the best part. This isn't just theory you're learning from slides. In your upcoming Lab 2, you're going to get your hands dirty. You are actually going to be applying these concepts and coding these decision-making models yourselves. You're going to build this stuff.
So there you have it. We've gone from simple rules to organized knowledge to strategic planning. We've basically laid out the building blocks of an artificial mind. But it does leave you wondering, doesn't it? If an AI can do all of this, if it can reason and plan and make decisions under uncertainty, what really is the true